Welcome back to All This Math. This is Professor Parker, and today we're doing some more circle geometry. Now take a look at this diagram that I've drawn right here and try to take in all the information in it. All right. We see a triangle. We see that there's a circle inscribed within a triangle, or we should say there's a triangle circumscribed about a circle. I'm not sure if I use those terms correctly. I'm going to have to look that up later. But at any rate, there's a circle inside of a triangle. Okay. Now, our task is to find out the measurement of W, X, Y. Excuse me. Our task is to find out the measurement of W, X, Y, and Z. And what we're going to do is we're going to use what we know about circles, triangles, arcs, angle measurements in order to achieve that task. All right. So I'm looking at this and like when I see a problem like this, I kind of just start looking and saying, okay, well, I don't really do things in any particular order. I just look and see what I know. All right. Like, what do I know? I know that this angle is 110 degrees. I know that this arc from this point to this point is 135 degrees, because that's what that means when you see an angle drawn on the edge of a circle, right? That's an indication that that's the arc measurement. All right. So from this point to this point is a measurement of 135 degrees. All right. Now, let me start figuring stuff out. Now, I also know that this angle right here where X is formed by two tangents to the circle. So from this point to this point, that's called a tangent. A tangent is a line segment or a line that touches a circle in exactly one point. It touches a circle in exactly one point. Remember, secants cut through the circle. Tangents like graze the circle basically, right? Tangents graze the circle. Secants go through the circle. So whenever you have an angle that's formed by two tangents, check this out. The measure of that angle and the measure of the arc that's closest to it in the circle are supplementary. Those measurements are supplementary. So what does that mean? That means that this angle right here, labeled X, and this arc right here are supplementary. So that means that X plus 135 must equal 180. X plus 135 must equal 180. So I'm going to use that to figure out what X is. X plus 135 is equal to 180. If that's the case, then I'm going to just use a little bit of algebra. I'm going to solve for X. I'm going to subtract 135 on the left, and I'm going to subtract 135 on the right. So now I got X equals, and 180 minus 135 is 45 degrees. Right? That's 45 degrees. All right, so that's 45. So one down, three more to go. All right, now, I know that this is 110. So again, same type of relationship, because this angle is formed by two tangents to the circle also. See, one tangent, two tangents. So that means that this angle and this arc are also supplementary. This 110 degree angle and this arc, which is represented by the letter W for now, until we figure out what it is numerically, are supplementary. So that means I'm going to set up another equation. 110 plus W equals 180. So if 110 plus W equals 180, how do I figure out what W is? I eliminate the 110. I eliminate that 110. The opposite of a positive 110 is a negative 110. So what I'm going to do is I'm going to subtract 110 on the left. I'm going to subtract 110 on the right. Now I got W is equal to 70. So that means that this arc is 70 degrees. So let me fill that in. Now, I got to figure out what Y and Z is. All right, now, let me see. A couple things I could do. This is a circle, right? All the arcs in a circle must add up to 360 degrees. All the arcs in a circle must add up to 360. So if I know that this arc is 135 and I just figured out that this arc was 70, there's only one arc left. The arc represented by the variable Y. So that means that this happens. Y plus W plus 135 is equal to 360. Y plus W plus 135 is equal to 360. I know that to be true. Now, I can't solve for two variables at the same time in one equation. I can do that in a system of equations, but this is not a system of equations. This is only one equation. But lucky for me, I already know what W is. W is 70 because we did that work right here. So now I could just say Y plus 70 plus 135 is equal to 360. And now I want to solve for Y. First thing I'm going to do is I'm going to combine these like terms. These are called like terms because they're numbers. All numbers are alike, no matter whether they're positive, negative, decimal, fraction. All numbers are considered like terms. So what is 70 plus 135? That's 205. So I got Y plus 205, which equals 360. And now I want to isolate Y by itself. So I want to get rid of any term that's on the same side of the equation with it. In this case, we talk about 205. So the opposite of adding 205, because that's how I get rid of things, I do the opposite operation from what it's already involved in, right? So the opposite of adding 205 is subtracting 205. So I'm going to do minus 205 right here and minus 205 right here. Boom, boom. Then I got Y is equal to, and then I got 360 minus 205. So it's just like money. So you had $360 and you bought some sneaks that cost 205, right? Let's see what you do. 360 minus 200. I'm going to just take 200 off. That's going to give me 160 and then take another 5. That's 155. So Y equals 155 degrees. Last but not least, we're going to solve for Z. Now we know, now again, and it's a few ways we could do this. Like, I know that this is a triangle, right? So we also know the triangle sum theorem. All three angles in any triangle must add up to 180. All three angles in any triangle must add up to 180. So if I know that, then I can say 110 plus X plus Z equals 180. So now I got 110 plus X. X is 45 though. I don't need the letter if I know what the number is. If I know the number, I don't need the letter. We don't need variables, right? Plus Z, I still need the variable Z though because I don't know what Z is yet. Equals 180. What's 110 plus 45? 155. Plus Z equals 180. Now, subtract 155 on the left, subtract 155 on the right, and Z equals 25 degrees. And now let me try something else. Because this is a good way to check our work, because in mathematics, if we can use two different methods, two different proven methods and get to the same answer, the same number, then that's kind of confirmation that we did it right. All right, or that we had the correct answer. So I use the fact that this triangle includes these three angles. I use the triangle sum theorem, what we call the triangle sum theorem, right? All three angles of any triangle must sum up to 180. But I also could use the tangent theorem, which said, well, part of the tangent theorem, which says that an angle formed by two tangents to a circle is supplementary to the measure of the arc closest to it, right? Y is the arc closest to Z. Y is the arc closest to Z. So that means that also Z, I'm going to write it up here, Z plus Y equals 180. Now I'm going to act like I don't know what Z is yet. Because I'm trying to check my work, right? But actually, no, I'm going to act like I know it. So is 25 plus 155 equal to 180? It sure is. So that's proof that Z is 25. All right. Another thing I want to do to check my work, I want to check to make sure that W and Y are 135. Well, I kind of already did that. Yeah, because all three of these arcs must add up to 360. And they do. So, again, just a little bit of work with circles, triangles, triangle sum theorem we used, the tangent theorem, tangent theorem. The angle formed by a tangent is supplementary with the arc closest to it. And remember, the arc is the pizza crust. If you consider a circle and a large pizza, then when you see the arc is the edge of the circle, right? That's the pizza crust. That's all it is. All right. So I hope this was helpful. Please like the video if you haven't already. Share the video with some people. Subscribe to the page if you haven't subscribed to the page yet. Let some people know about it. Let some people know about what we're doing over here at All This Math. And as always, do remember, there's all this math all around you. Peace.